Hello, everyone. I'm Andrew David, Editor-at-Large at Elemental, and I'm delighted to introduce the second of this week's webinars, which are focusing on heat networks and district heating. Now, excess heat has been described as the world's biggest source of untapped energy. So this session is going to take a closer look at the potential of reusing this waste heat. I'm delighted to welcome a panel who know a lot about waste heat and the potential for capturing it. So please welcome, in alphabetical order, Brian Churchyard, who's Managing Director of Omega Solutions, Andy Ford, Director of ICAX Heat Pumps, and Kristina Roszynski, who's Director of the Green Skies Centre of Excellence in Smart Local Energy Systems at London Southbank University. We'll, of course, be allowing time for audience interaction, so please do, if you have a question, put a short and succinct question in the Q&A section rather than the chat, and we'll try to get as many as we can. Yesterday we had a 4-paragraph question, so please try and keep them a bit shorter than that so we can read them out. So let's go straight in and talk about waste heat in detail. I'm going to ask the panelists to introduce themselves and then to give us their take on the subject. And we're going to go in alphabetical order. So Brian, you've been capturing waste heat from systems for many years. Please tell us where you see it going in the wider sense.
Yes, so that's exactly right. So my current role, Brian Churchyard, I'm Managing Director for a company called Omega Solutions, which is an engineering energy net zero business, very much independent business focused around providing clients, customers, end users with a kind of a version of options available in terms of engineering solutions. My background, I was for 15 years head of engineering at Asda, and then for a period of time head of the construction model for Asda Stores Limited. So anything that we looked at from an engineering perspective, you consider the size of a state of a large supermarket, and anything that we could do in terms of energy reduction, energy savings, ultimately making the business more profitable at the end of the day, but whilst also reducing business's carbon footprint was of keen interest specifically to myself. Taking those learnings from my 15 years working as a large end user head of engineering into the business that I now run with 2 partners is really quite valuable to me. Specifically to heat recovery, heat waste. Probably around 2011, we implemented into the construction model store for Asda certainly was a heat recovery solution that was very basic in its form, but basic on the basis that it had to be something that offered a return on investment. So the approach to heat recovery was specifically of the refrigeration system, capturing the waste heat that's generated pretty much 24 hours a day, 365 days a year, and then using that heat that would otherwise be wasted to atmosphere, capturing it into a water loop system, and then bringing it back into preheat for the building. And in some instances, it was for preheat for the building, or it was provided as preheat to hot water supply to the building. And that's something that has been in place for the new store specification since about 2011. Technology is moving on quite significantly. New opportunities are now showing themselves. I think one of the biggest challenges that we certainly have is its affordability. Yes, the heat is there. Yes, the heat is available. But capturing that heat, harnessing it, and effectively putting it where you need to use it is quite a costly exercise to do that. And definitely the technology is moving forward, which is fantastic. But yeah, it's certainly an untapped opportunity. But I feel that one of the barriers is around the cost issue of it to kind of help it move forward and move on. So a bit of my background, a bit of my thoughts, where I've used it previously. And then over to whoever else.
Thank you for summarising what you've said. That's useful. We'll be coming back to the cost element, I'm sure, in a minute. Now, Andy's. I was thinking about this. I heard Andy talking about the concept of moving heat around. I think that was the way you phrased it. More than a decade ago. So clearly something that's been on your mind a long time, and now you're putting into commercial practice, I guess. So yeah, would you like to tell us about the the world of the big heat pump.
Yeah, I will. Yeah, a decade is probably an underestimate, sadly, as to how long I've been thinking about waste heat. I now am ICAX. I'm director of ICAX. ICAX has been running. I've been the director of it for 20 odd years. In truth, it's evolved and become a manufacturer and installer of heat pumps, large scale heat pumps. We've done lots recently, but my interest in heat has been lifelong almost. It began, I suppose, in the 1980s when I did a project when I was working at Max Forderman Partners for a thing called Otterbourne Southern Water. They did their new headquarters building, and they had a big heat pump, big pump actually, not a heat pump, big pump, which I couldn't bear seeing it running because it was a huge thing, and it produced water at 80 degrees C to cool itself down, and I needed 80 degrees C water to heat my building up, and it was just sitting there going, and I thought, oh, you can't do that, that's silly. So I persuaded them to put some pipes in and link the two things together, and it worked, and worked very well for a long time. And then onwards from that, I set up my own company. God, 1984, and that was a rethink of what heat is all about, and it was trying to understand. Really, it comes down to temperature. What temperature do we want? What for? And where is it? And is it in the right place or the wrong place? And what do you do about that? And is it the right time or the wrong time? So those things have to be solved. So that actually led me to doing university buildings at the University of East Anglia, where the first sort of heat recovery systems went in. And they are simple. They're what you do a lot these days. They're just ventilation system with a heat recovery. But at the time, in the sort of late 80s, it was revolutionary. We had to actually design our own heat recovery ventilation plant from scratch, which was like mad. Now you just buy them off the shelf. But that was really interesting, and it realized that what we're talking about is, what do you mean by waste? What do you mean by waste? Our body temperature is 37. Our ambient comfortable temperatures, we need to lose heat to be stable and comfortable, about in their 20s somewhere. So everything else in a building where we're talking about is really a potential, not a waste. It's just not used. So we have to think about how we make use of what is available when. And that initially starts with ventilation, heat recovery, seeing if you can use thermal mass to store heat. That's where it all begins. And then you realize that's fine. That's fine for individual buildings. But then you think, actually, what do we mean by waste? And you think of bigger scales, and you start thinking of, well, industrial plant. Yeah, I can see why they may need 1,000 degrees to melt something, and then afterwards they don't want it melted, so they've got 700 or 800 degree temperatures which are just thrown away. That is waste. And then we have waste which is cooling. So we have buildings that are too hot because they're occupied all the time. And ICAX has done a few of those, like their buildings are those sorts of buildings. They're prisons and hospitals, which are heavily occupied. You have to cool them down and throw the heat away. And throwing the heat away has always been the bits annoyed me, really. It's just sort of, I need it later. Why can't I just have it then and put it somewhere? So heat storage, heat banking in the ground, has led to the design of interseasonal heat storage, so aquifer thermal energy storage, which is used extensively in Holland. Pumping water into the ground, taking water from the aquifer to cool a building down, warming the water up, putting it back in the aquifer, taking it out, using a heat pump to heat it up, putting the cooled water back down in another borehole, all those sorts of things, which is where ICAX has gone to, really. And in the process of all that, I met the CEO of ICAX, Marquez, who's started life as an architect, and I was teaching architecture students about heat. He's evolved into a very, very good engineer, and and now runs a heat pump company. So heat is a thing I think is fascinating. We have to work out how to get the wasted heat at the right temperature from all the places it ends up. And typically at the moment, things are like that are sewers, rivers, the sea, the air. Anyway, that's where I am. I'm currently designing heat pumps, manufacturing and selling heat pumps, because I think that's the solution to the problem. I hope that helps.
No, that's very good, Andy, and right on cue. I was just about to say we might have to busk for a little longer because Kristina had disappeared from view, but right on cue, she's appeared in vision, and so you probably missed the last couple of minutes, but Andy's been manfully talking about various sources of waste heat, and he happened to mention that his boss or his colleague was or is an architect and then became an engineer, which very neatly segues us across to another architect who has an overview of these things, and it's you, Kristina. So would you like to tell us about your perspective?
Yes, great, thank you. I did have audio, so I did actually hear.
You could hear what was going on. Great.
I could hear what was going on. Fantastic. Well, thank you very much for the invitation to speak today. And as you said, I'll be speaking from my perspective as a practicing architect at Cullinan Studio, and also as another role that I have, which is director of the Green Sky Centre of Excellence, which is based at London Southbank University. My interest is on the challenge of heating existing homes, because I think if we're going to meet our targets for 2050, then we really need to focus on existing buildings and particularly homes, because a third of emissions come from this. So the Green Skies project, which is the name of the Centre of Excellence comes from, that we've been working on for the last 3 years, is an example of one solution of how you can get heating to homes in urban areas. So this is a project led by Southbank University, funded by Innovate UK, and we had the London Borough of Islington as one of our key project partners alongside the community, which is a very important part of the project. So Green Skies, it's a smart local energy system, which is a heat network that can deliver low carbon heat, power and mobility. So that's important because it's integrating these things, and it's utilising waste heat source from a local source. So in this case, it was a data centre, and that could deliver something of the order of 80% carbon savings annually. So I think from what I learned on that project was that we really need incentives to harness this opportunity of waste heat, which is clearly there, and the research that we've been doing at Southbank University, we can see alongside work that's been done by Helga, others like Bureau Happold, that it's significant. You know, it's something, you know, in the order of 60+% of our space heating and hot water demand, particularly in London, could come from waste heat. So I think that, you know, we've been looking at feasibility studies around the UK, so looking at wastewater treatment plants, supermarket, glass factories, mine works, which are all viable. But how do we actually make, you know, fast track these projects to happen? So, you know, one thing in Europe is that they are looking at making it mandatory to heat capture. So that approach could unlock a lot of investment in the UK. As an architect, I always believe in the kind of whole systems approach. I want to look at how we integrate heat pumps, heat networks, and the retrofit of buildings as well. And I think, you know, finally, I think we need a sort of innovation in terms of culture. I think a lot of the barriers are non-technical, I would say, that they're around the sort of cultural thinking that we have about the energy market. So on Green Skies, we have a language where we talk about co-benefits projects. We talk about sharing heat, and also that could be cooling as well, which is an important aspect, which I think you mentioned. in the introduction as well, that not to forget cooling, which is something that's going to become more of an issue in the future. And I think that this kind of new language around sort of what I would call net zero positives really needs to bring the community with us on these type of projects. I think that we need a real kind of commitment to effective public communication. So I've covered a lot of ground there. Yeah,
you have indeed. I'm wondering where to start picking up on all these things. I guess the really interesting sort of first way in is just to consider. You said that the barriers are probably cultural, but as Andy has said previously, there's a lot of waste heat sources around. You've said that. I'm imagining it's not that easy to. I mean, you'd like to think in an engineering sense, you just tap into them, but obviously that is far from what is possible. I guess you've got permissions and all that kind of thing to think about. So how do you go about approaching this sort of crossing these barriers?
I think one thing that I think is important, and Andy touched on it, is there's a difference between potential heat and waste heat. The waste heat for me is something that's created out of a process or a system, a mechanical system, whatever that might be, that is, you could argue, is inherently has inefficiencies built into it, then creates that waste heat, which is ultimately energy. And what you're trying to do is recapture that energy, that if you can at source make that solution more efficient, therefore the heat that's coming off it will be less. So we're trying to make a system more efficient. So if I take it into my old world of refrigeration, that the waste heat that's generated from a refrigeration system is heat that's wasted because it's generated by the refrigeration system. The more energy efficient we can make the refrigeration system, therefore the less waste heat we're going to have come for the back of it. Versus what obviously Kristina and Andy are talking about is I think Kristina's more about kind of both sides, is what does waste heat and potential heat look like. But certainly what Andy was touching on there is when you look at the available heat in the environment, whether that's in aquifers, thermal mass that exists in the ground, that is heat that's available to use. And how do you harness that, package it up, take it and put it where you actually need to have it, versus a refrigeration system, for example, that is its purpose is to cool things down and therefore creates heat at the end of it. So the objective of that, first and foremost, is how do I make that system produce less heat, is more energy efficient, so I therefore have less heat to harness and do something with, versus take the opportunity to enhance what already exists naturally, potential heat versus actual waste heat. To me, there's kind of two different things that we talk about there.
I think that's true. There are two different ways of looking at it, and efficiency, I think, is core to it all. But actually, I think the most important thing we're actually going to be working towards is the total system efficiency. So from the generation of electricity, I personally anticipate that the future is entirely electric. So let me get that out there, just a view. But the process of getting that electricity into the form that we need it, using it in the most efficient way, is going to be what we're going to have to concentrate on. And there's two ends to that. One is the sort of the power generation side of it. And there's, as you say, I mean, whenever you convert one energy to another energy, there's waste. And what that waste is heat. So there's always any conversion that we have to do, we are going to create a waste heat. Those places are not convenient. That's my personal problem with that, is that they are trying to get a heat recovery system at scale that works in the city is challenging. It's not impossible, but it's challenging. It's going to take time to implement. That's why I've become really interested in where the heat ends up. So why cooling rivers and things and sewers and things like that, which are already distribution networks across a city, where they potentially have. We did a nice little bit of research at Southbank when we were there, which was looking at sewer heat recovery. But the trouble with the sewer heat recovery is actually the best place to recover the heat is at the sewer station. So Beckton has 1.5 terawatts of heat available spare, but it's in Beckton. You know, nice place and all that, but it's not really going to solve the centre of London problem. And that, I think, is where ambient heat networks potentially can come in, where you are sharing heat, as you described, Kristina. They're networks of sharing heat, and I think if you link those, which is what we're trying to do with another thing at Southbank, was the balanced energy network, which is trying to show how thermal storage in aquifer in buildings can help the energy supply companies manage because our future energy system is not centralized, it's distributed. So how we can actually help that happen, so we can use buildings to change when we need electricity, and in the same place give us cheaper electricity, those sorts of things. So I think getting the heat to the right place is the challenge, and I keep looking at what networks do we have in place already which we could use potentially in some way, because it's pipe work in the ground. And I have one which I've never said before, but I'll tell you. Which is
it an exclusive? This is what we want to hear.
It's good. We're going to throw away all our gas pipes and they're going to be empty. So, we've got another one, but
yes.
But I don't know how you use it for the life of me. But distribution. I think most of our cities are either on rivers or sea or aquifers. All of those make me think that heat storage is as useful as to get waste heat as anything else. And we should try and find ways of using those existing networks to link things up and then make it really cheap to get the heat, otherwise nobody will do it. So.
Okay, that's interesting. Kristina, what do you think about that?
Yeah.
What I wanted to say is, what's it like in the real world of? So the real world of Islington because I guess one of the things that people looking in are going to go, yeah, those guys at London Southbank, they're really good at getting these ideas, but you want to go and talk to the local authority and see whether you can convince them. But you've done that, so
yes.
What's the key?
What's the key? Well, yeah, I mean, there's no silver bullet. That's no surprise to find that. But yeah, I mean, I can talk from my experience also at Cullinan Studio of working on, we also worked on Bun Hill 2, which is using waste heat from the London Underground, which is a kind of world first. So I think that, one thing that I was going to say, Andy made a good point about the low temperature network. So this kind of ambient loop, which to my mind opens up more opportunities of using this potential of recoverable heat. And I think that understanding the motivations of people connecting to these heat networks. So for example, in Islington, the data centre, I was kind of surprised, but good to find that one reason they wanted to connect was for their recruitment of staff. They wanted to be able to say that they were doing something positive in the community.
Okay.
So actually their drivers weren't necessarily financial, they were other reasons. So I think that we have to, widen our understanding of people's motivations and, offer them kind of solutions. And I mean, the data center example was also about not just taking heat, it was about selling them cooling. So that requires a more innovative business model. So we need people working on this side. You're asking what the technical, I would say they are, but I think we have the engineers to overcome that. The challenges are around things like business models, behavioural challenges around the sort of culture of how companies work. So I think it's things like that we need to kind of have a different language of how we talk about projects. But I think, there are lots of heat networks which need to decarbonise. So there are ones that, we've worked on in the past, which were originally gas, CHP, and many of those in the country which now need to decarbonise and move on to being electric. So I think, things like the Olympic Park is one that I've been to visit recently, and I know they're doing work on how to decarbonise that, and maybe that's the sourced pumps. So I think that to my mind, we're in this transition period, which is a very interesting time of, the technology thing. And so, but there's like,
can I ask a question?
What we can do? Yeah, please.
So Kristina, the language I think is really important. And teaching at Southbank, trying to teach building services engineers, I've been very hard work at trying to get them to communicate, because they work in design teams and it's really critical. But I was wondering about that language. Have you found what ways have you found that work? What words have you used to convince non-technical people about things? Because they tend to go blank and it all goes a bit much.
Yeah. I mean, the project with Islington was really interesting because we worked with the community from the beginning all the way through, and we started with them to ask them, what. And this was during COVID, so it was an interesting time anyway. What's important to you? And they told us that air quality was more important to them than carbon.
Yeah.
So then we started to frame how we explained the heat network around things like, air quality, and, how energy security, that was more important because at that time we also had increase in energy costs and war in Ukraine. So for the first time, people were thinking, where does my energy come from? Which energy is very abstract, I find. So it is difficult to talk to people about it. So before, no one thought about where their energy came from. That the war in Ukraine changed that. So energy security. So explaining this decentralized system, that's a real positive because it's sort of locally generated energy. And then from that, you can start to explain how, if it's decentralized, then there are other kind of benefits to that, you can make it more efficient and,
topical
technologies. Yeah. So I think, the other thing to say on just going, something else that you mentioned about Beckton, wastewater treatment plant. There is actually, it's right next door to Barking Riverside, which Alan and Studio are working on with Barking Riverside Limited, and there's going to be like around 10,000 new homes being built there. So, we're having that conversation of, look, there's all this potential recoverable heat, your heat network.
So the other thing that I was about cooling. I'm sorry, was about cooling. So when we started looking at aquifer thermal energy storage in my company a while back, the companies in Holland, they sell cooling. That's what they sell, because it's of higher value to people in flats than. It sounds better to have an air-conditioned flat than it is to have one that's just got central heating. And so they take the heat from the flats, which are overheating. They store it, and then they sell it back to them as heat afterwards. So you sell them cooling and you sell them heating, and it's the same thing, only 6 months later. And I always think that in there is a business model somewhere.
Exactly. No, I think that's really interesting, and I think that's going to become more topical, and the not distant future of cooling. And
I think cooling of buildings is acknowledged. As Climate Change Committee have been banging on about it. I was going to say that's the wrong phrase, but urging the government to consider overheating in buildings for quite a long time. And I think, we have to get to grips with that. And you're right, there's equally there is a source of cooling out there. We talk about excess heat, but there's no reason why we can't talk about the cooling as well. What I want to know is, we've got these sewers, you've got these rivers, but who's making who's responsible? Who makes the decisions? If you're considering this network, somebody presumably has to go cap in hand to 8 or 9 different authorities.
Yes.
Water company, local authority. And that's, it's a bureaucratic issue as much as anything else.
Yeah. Well, the complexity of the relationship is another issue, and that's something we can, we all need to work on. Is we have to collaborate. I mean, I think that's kind of one of the kind of questions is, how do we do this? Well, not on our own. We have to collaborate with lots of nations.
I mean, the sort of the perception is that there is, as Brian alluded to earlier, the technology is out there for heat exchange and for recovering heat from a variety of different sources. The next step is making that source available, and then I guess, and then making sure that it's then used. It appears to be the situation at the moment. Correct me if I'm wrong, that there are all these potential sources of heat to tap into. We've been talking about, I'll bring it up again. I'll probably say it too often. The river source heat pump, back in the days of the coalition government, when Sir Ed Davey was energy minister, got very excited about the river source heat pump at in Kingston, I believe it was. Yeah. And we thought this was and I believe there was even there's a map has been produced of all the potential river sources for heat, and everyone got excited about this new great potential for tapping into. But we haven't seen a revolution in river source heat pumps, and I'm presuming
you've hit on the main problem: politics, frankly, and it's
a
huge issue. Continuity of decision making in this world is insanely. It doesn't exist.
It doesn't exist.
So we have currently, obviously, we've still got the all the tariffs on electricity, which are supposed to be driving it to become low carbon, and next to no tariffs whatsoever on gas, which is a high carbon fuel. And you think, oh, well, until we get we sort this little issue out, things won't happen. And then we have. It was 2016, I think it was, zero carbon homes the Labour government had planned. I was in there was a thing called the Zero Carbon Hub, which was based in my office in Rosebery Avenue at the time. And that was really interesting because it was around it was 2010, 2011, that sort of period. And it was put together by the UK Green Building Council, and they brought together a group of people who were developers and people passionate in various industries, and then brought in the institution to talk to each other. And we used to hold debates about how you might do it. And then we had a change of government, and the targets were just cut. We no longer have the zero carbon by 2016 target. So all the developers stopped being interested. That's not fair to them. They haven't stopped being interested, but you need a consistent target. You need stages of how you're going to force it to happen, and then people will find the business models that make that happen. But if they know it's going to constantly change, it's not worth their effort. They won't put it in because you can't be sure what business model will work. And any business model's got to work for a long time. It's no use if it only works for 5 years and then suddenly that's no good for anybody.
You mentioned earlier this concept of mandatory use of waste heat in the Netherlands. And I was thinking, I was going to just throw this back to Brian. We've been talking about use of waste heat in refrigeration for a long time, but it's still not universal by any stretch of the imagination, is it, Brian? And as you say, in that world, it's a commercial decision, and that's partly why it's not universally applied.
I think there's some there are some parallels to what Andy has just mentioned there as well, though, is that even in a commercial environment, the leadership changes. So that leadership tends to look at the short term, because they'll look, I might be enrolled for 2 or 3 years, and then there'll be somebody else coming along. In the same way, the government is in place for a period of time, and then something else comes along. So I think there are certainly some parallels in that. So what tends to happen is, in the commercial environments, they always look at a short-term payback, whatever the technology is going to deliver, not what does the next 10 or 15 years look like, because in the next 10 or 15 years, leadership will have changed 5 times over, maybe even more so than that. So it becomes quite a difficult decision point for an organization to make, that says, well, I'm going to deploy my CapEx year 1 to see the benefit in year 15 from a commercial perspective. Because everybody at the end of the day they've got their jobs and their own targets that they need to deliver. And I do think there's probably some parallels there on a much wider scale, much bigger scale, when you look at it from a national government decision-making perspective. You know, what is right for me today is not necessarily right for me tomorrow.
But these are all long. You know, the world that we're talking about, the heat network, are all long-term scheme. You know, there's no quick fix.
You can't fix a 200-year problem within. Sorry, my earpiece dropped out. You can't fix what is a 200-year problem we've created within 5-10 years even. I mean, it's going to take time to be able to unwind and undo what has been created through that time. In the same way. But the reason why we're in a 200-year legacy issue is because it was driven by commercial profitable gain. So arguably you could say, well, in order for us to get back to that place, there has to be a commercial profitable gain with the technology we're going to be deploying. So how do we make it affordable? And that comes back to my original comment that I made around the waste heat that ASDA harness and capture on new store build was done in an affordable way. So the return in investment was attractive to the leadership at the time, that said, right, so I'm going to see the benefit of that in the next 3 years. I'm going to see my money returned in the next 3 years. Well, yes, you are. And actually what we're also getting is a carbon benefit, a kilowatt hour reduction. There was another point that you made, or a question that you asked, Andrew, about the non-technical conversation. And what you saw Andy open with was relate heat to the human body, to try and bring it into something that's a bit more understandable for a non-technical environment. And that is always difficult, because engineers talk in letters and numbers. We talk in kilowatts, we talk kilowatt hours, we talk about things that just make people go, what? Because that's our language, that's our world. And the challenge is, to Kristina's point, is how do I make the opportunity attractive enough that is away from, well, engineer it because it works, because it just works, but how do I bring it to life and make it into something that is you know, it's almost like you're not just an engineer, you're a technical engineer, you're a sales engineer as well. You kind of need to bring the two together. So I think there are comparables when you look at commercial world all the way up to government on very big projects. And it's, you know, money's too tight to mention, right? I mean, it's a real challenge.
So I can't believe you brought Simply Red into the conversation. Should we just let Kristina respond? It's Kristina's turn now to speak.
Thank you. Thank
you.
All right. After that Simply Red reference. Yeah, I mean, what I was just going to add to that was what I noticed changing. Obviously, it would be great to have a government that was pushing forward, but what I call a pragmatic optimist. So I try to be positive. One is around ESG, so investments that companies do have to respond to that, particularly, you know, ones who have shareholders. So I think that, you know, when companies are and large landowners are setting these targets, regardless of what's happening at national level, they seem to be just getting on with it because they're being held to account. And so I think that, you know, which kind of shows that the whole investment community has a huge part to play in this journey. So that I think is, you know, is one sort of positive. And, you know, I think again around the sort of language that's, you know, really important about selling. Yeah, we are trying to sell solutions, and often the people making the final decisions are non-technical.
Right.
So we have
Good
to
point.
be able to kind of explain things, you know, in a way that they can understand.
You're right, though, Kristina, because the carbon reduction, we shouldn't underestimate the momentum coming from carbon reduction and net zero and those kind of goals for corporate governance, because we're starting to hear embodied carbon questions left, right, and centre, which never existed 5 years ago, and because we shouldn't shy away from the fact it's because it makes the company that's asking look good, which is it's because they want to show that they're making progress, and this is taking it back to the waste heat scenario. This if we can capture waste heat and reduce energy, this is going to look good on on the corporate balance sheet and also on the sort of ethical balance sheet. Go on, Andy, I'll let you back in now.
So, I mean, I was just interested in Brian's comments as well. It was, so, I mean, when you were doing your refrigeration, would you just keep that within the building? That the efficiencies and things they just used within the space, because the snag with
just for that.
The snag with the problem you have with waste heat is it's fine. There's a supermarket there. It's potentially a source of heat, but then it might not be there forever. So it just vanishes, and you've got to have something else that comes in. I do think that I think some of the landlords are getting involved because they have a longer term thought process. And I do think that's really probably key. And similarly with the local authorities, which they've declared climate emergencies, and they potentially, I don't know how quickly you can undeclare a climate emergency, but potentially it gives you a way to have this longer term targets. And I think if we can get those longer term targets in, no matter how they get in, then the engineers can start to work towards creative responses to them, and then it all starts to work. But so it almost has to ignore. I think the pragmatism is absolutely essential. You have to ignore all the big stuff and concentrate on what you can do. And one of the things I do like about so trying to get the university to do anything was an interesting experience, because I've previously been a consulting engineer, and I'd gone off and told them, and suddenly I'm embedded in this large organization trying to persuade them they should put heat pumps in. And I didn't tell them that we just won an award of £4 million to do it on their campus. And then I had to have this discussion with the man at the top, explaining.
Actually, applying it to commercial.
Well, I'm going to do this.
Yeah.
Well, the one I'm sitting in, and the one just down the road, and yes, there is a little road in the way. Oh, yes, and you do have students, and yes, I promise it won't be disruptive. Honest. So, but yeah. But trying to get, and it was done, by the way, and it does.
I'm going to say, did it succeed? Yes, so
it worked really well. But that whole confidence, if you like, I think, is how you talk to the right people. You have to find your way to talk to the right people. And those right people are quite often farther up the ladder than you are used to talking to when you're an engineer. So you have to get to the point where you can explain things in simple enough language, clearly enough, with the figures when it comes to numbers, particularly money, and particularly the impact, for instance, of me disrupting lectures over a large period of time, which, their main income is students. They were quite keen that we didn't disrupt those lectures or the exams. So you have to understand what people's problems are so you can respond to them. And I think part of the education of engineers, if they're going to be able to make heat networks and things happen, has to be about more than just the engineering. It has to be about how to understand what organizations are going through and what their long-term aims and short-term challenges are, and how you speak to respond to them.
It's a very interesting point, and it's something that came up at the on the webinar yesterday with the folks who are providing the funding for network building and for network efficiency. It's almost like we need a new industry or a new sector, because it's so the heat network, it requires so many different parts. You've got to sort of knit them all together for them to work. And for many people, the waste heat area is new and untapped, with all the puns intended. And yeah, and I think it's being alert to all the possibilities, but then being able to follow them, to then build on them. I think that's the challenge. You'll notice that one of my questions that I put to you was, what's the low hanging fruit when it comes to tapping into these sources? It's what do we do? We've got people on the call who've considering heat networks or have heat networks. Can they go to their nearest data center operator and say, we need to talk? How does it work? I'm still on the same question as I began with. Sorry, Kristina. How does it work?
Yeah. Well, I mean, I can give response to that. So that's why we set up the Centre of Excellence at Southbank University, was to support people who want to do these projects and don't know where to start, because we've been through this process and we've stayed together as a consortium, and the idea was to kind of have got a website, we've got resources, and that goes from everything from experts in community engagement to people who do energy modelling. So it's the full kind of spectrum. So I think that's the kind of support that people need, so that they can, at whatever point they are on the journey, they can come in and get some advice, support on what the next steps are. So I think that's what we need, more of that collaboration. Yeah. Because it's in all of our interests for these projects. And a key part of them often is funding, so applying for green heat network funding. So getting advice from people who've been through that process. It's not an easy process. And I think one of my other comments about that actually would be to government, is that there's a very short amount of time to spend the money if you do get funded. Right. Which I think is an issue. I mean, it sounds like a good idea to say, right, you've got 12 months to spend it, but not when it's large sums of money, and it's really hard to move that fast. So it helps them with accounting and not with the engineering. It does. So exactly. It works to their financial years, but actually when you're on the ground on a real project, it can push things, to make.
You make wrong decisions.
So I throw that across to you, Andy, because you're sort of taking a different tack. You're trying to sell technology into these sort of networks. Do you go in there with, when you're making your application, saying, I've got this supermarket next to me that we're agreed that I can have their heat, or is it not that simplistic? I'm imagining not.
Well, you have to find who to talk to is the first challenge. If you're on the outside going in, and that might be. Usually, there's an individual somewhere in the organisation who is really interested in these things, and you have to find them. They may be in the property section, maybe in the engineering section, or they can be an accountant just as easily as anything else. You have to find that individual, and that individual then will introduce you to the structure of the organisation, and you can start to talk to them, explain to the possibilities. I mean, it was interesting. We've just done a large scheme in Southwark with introducing heat pumps into existing few thousand homes, and that combined with their existing district heat network. And that was really just interesting, because you had to find the person in Southwark, basically was somebody who was their energy focus was for the whole of Southwark, and they were interested in the whole thing. And then they had to prove to their superiors, obviously, but then also their contractors, those contractors who were already embedded in their supply side, they had to understand it so that they could work out whether they could do it. And the trouble is that they can't. So we then have a challenge, because they will say they can because they're trying to get the job. But the truth of the matter is they don't have the experience. And what will happen if you're not very careful is you end up with an installation that doesn't work, because they've tried to pull together people who say they can do it, and they can do bits of it, but they can't do the whole thing. So there is a role for somebody, and ICAX has played this role in several places, who does have that particular pull it all together expertise, and then does monitor it, does make it go all the way through. Because unless you take it from the beginning to the end, when we first tried to introduce aquifer thermal storage at my consulting engineering, we did a scheme, and it's called Westway Beacons, and it's a housing project out on the Westway, as it sounds. It's the only, I think it's the only housing project where the social housing has actually got cooling embedded in it. But it's there. We got a contractor who could drill a hole, a contractor who could make the heat pump, a contractor who could put in the pipes, but there was nobody to pull it together apart from us, and somebody who didn't understand. And that is a recipe for a disaster. It wasn't a success the first time round, but we've been back and it's been fixed and it now works. But this is the problem. It's a complete system. It involves talking to. You need to know who you've got to talk to, not just in the organisation, but in the sort of the local authority, and then the environment agency and the water boards, and all these people you've got to know. You've got to know how. You've then got to talk to the engineers in things like the supermarkets, who can understand what you're trying to do, what you need from them, what they need from you. So it's quite a complex structure, really. And I think Kristina's organisation is very, very useful. You need both the technical and the understanding of the whole thing, and who to contact who to make this work.
Well, I also like to think that talking about these things helps, and this kind of discussion, because it throws up some of the considerations, because from looking in on the industry as I do, there's nothing worse than you see people with great technology and technical ideas who have nowhere to go with them, or who can't link them up with the right people. And maybe there is a discipline that we're missing. But the opportunity is great, and it's when we're in a world where there is a great opportunity, we've got to try and work out a way to actually exploit it, don't we? Because often we don't have that opportunity in front of us. There is a question that we need to deal with, because it's an interactive session. It's just about ambient heat networks. So somebody's just asking to perhaps you can flesh out a bit about because this is the new generation of heat network, isn't it? Ambient heat. Are they suitable for domestic circumstances, or is it only for public facilities? Now, that's the question. Anyone want to answer that? Who wants to tackle ambient heat networks? Kristina, it's probably you, I have to say.
I can start, and then the engineers can.
And we'll bring the engineers in.
So yeah, I mean, from the example of Green Skies, that was Islington. So we were connecting domestic buildings to that temperature, and then we had energy centres with heat pumps in, which would increase the temperature of the heat, so that it would then go into the homes. So in an ideal world, you would want it to run at a lower temperature and not need to do that, but do that, you'd then have to either increase the size of the radiators or retrofit the building in some way that it could operate on a lower temperature. So that's my example from Islington. But if you're talking about a single home, you could connect a single home to a heat network, and Kenza is
social housing.
Social housing
setups are doing that quite a bit, aren't they?
Yeah. So that is possible. So it can be used in that domestic scenario.
So the question for the engineers then is why aren't they all ambient heat now? There's a reason, isn't there? And I'm supposed to know it, but
why aren't they all ambient heat networks?
Yeah, why aren't we all on ambient ones now?
It just takes time, I think, is the answer.
Right.
I mean, it's so just to be clear what we mean by an ambient heat network. We are talking about temperatures of the sort of 15 to mid 20s as a way of distributing heat, which obviously is no use for heating a building. So when you come off a building, whether it's a large building or a small building, you're going to need a heat pump to change the temperature of things. And heat pumps are, our ambient heat temperature at 15 to 20. You can get very efficient heat pump working on that, delivering high temperatures to your existing heating systems. Interestingly, one of the things that is interesting is CIBSE have, for a long time, have been forcing the design of heat systems, and there's always an over-design involved in heating systems when you are designing buildings. So for ages and ages and ages, you put in a percentage to enable the thing to be turned on and then go up to temperature, which is typically sort of 20% of heat loss. And then you've added on another 20% because that's considered good practice. So in truth, you have a thing that is probably 30, 40% bigger than it actually needs to be on steady state. So there are different ways of looking at how you heat a building and what you need to do in retrofit circumstances. And that means that you have to go into a retrofit building, see what its actual heat loss is, and model it so that it, for a heat pump, is actually what you have to do, which is a different way of heating to a gas boiler. But the answer is the whole point of the ambient heat networks is you can lay them across a village, or you can lay them across a housing estate. They're perfect for that, but you do have to then have distributed heat pumps to raise the temperature.
So it's again different ways of looking at how we distribute heat, which is, I guess, why we're here. We are coming to the end of our hour. Unbelievably, we've skirted across many subjects, but now I have to leave you by saying what's the one? It was my question 7B, which is, what is the one takeaway that you think the audience should leave with from talking about waste heat? I'll start with Brian. I'll do it alphabetical order again. So we'll start with Brian. What's the one takeaway, Brian?
If I'm going to talk from a more commercially sensitive perspective, and I've said this on other events that we've done previously as well, is that in order for a technology to be ecologically sustainable, it needs to be financially sustainable as well. In order for it to really kind of get traction, move forward. And that's the biggest challenge. It goes back to what we just talked about, is the short-term vision versus the long-term vision, the short-term benefit versus the long-term benefits. And I think you're always going to have that push-pull that's going to exist. The conversation as you go up the tree, so to speak, in any organization, is probably the less technical the individuals will get, the more skeptical they'll become. And it's always a challenge to overcome that conversation. But I'd just say ecological sustainability and financial sustainability need to go hand in hand to make a success.
Thank you, Brian. Andy?
Well, I'm probably going to just agree with Brian. I think if you want to make this happen, you have to do something that is going to make it a very attractive business to get into. And if you do that, you'll find they expand extremely fast. And I think the most obvious is just removing the penalty for using electricity. So remove those tariffs, make them sensible, and you will suddenly change the business model to something that people think, yeah, I can make some money.
Okay, that's I'm wondering how easy that is, but it's a takeaway. Okay, Kristina.
Yeah, well, I mean, I would agree with what Andy and Brian have said, particularly around the cost of gas compared to electricity. That's probably the biggest barrier when you're looking at the financial modelling. But I might say something which is non-technical, really, which is about sort of effective public communication. So I think that you know, when you're just sort of listening to the radio or hearing conversations, there's a lot of negatives around heat pumps. There's a lot of bad stories in the press. Some of these relate to kind of the fact that previously it was an unregulated space. And I think there are lots of issues around tariffs, which were like non-domestic tariffs that were applied to people's homes who were in community systems, things like that. None of that nuance is explained when the problems are, you know, explained. So I think we need a bit more sort of public information around, you know, what heat pumps are, what heat networks are, what the positives, because I think then that will sort of trickle up, like, to people in organisations making decisions about how to decarbonise. I think the general energy literacy level in this country is quite low, and that's what we need to improve.
Excellent. Thank you. Yes, so we need to continue the conversations. We need to keep talking and talking in an understandable way so that engineers and the public and the people that make the decisions on the money can all be involved. A fine way to conclude. So thank you very much to our speakers. I think a fascinating overview there and much more to think about. The webinar will be available to view shortly on the Elemental website. And if you're not already, please follow us. Follow Elemental on LinkedIn and sign up for the newsletters at elementaldigital.co.uk. We are having a third webinar tomorrow on district heating, and we're really going into detail. We're talking about heat interface units with our friends from Altechnic. So more details on that on the website. But certainly there's a lot to be thinking about and a lot of opportunity that we've heard already in the last couple of days. So great opportunity for reducing carbon. Let's talk more about it and let's move the discussion forward. Thank you once again. Thank you to all of you for tuning in. And we'll see some of you tomorrow and on another day. So thank you very much and have a good rest of the day. Goodbye.